Hello and welcome back to Calculus 3. This is the review for exam 2, part 2. So last time we already talked about the list and everything else, did a few problems. And the first problem of today is the chain rule. Now, what I see is that function q is the function of three variables x, y, and z, and each one of those is in terms of t. So, to find the derivative of q in respect to t, I would have to follow each branch and add all the derivatives together. So the derivative is equal to partial q partial x, because it splits, right? And then dx dt, because it goes straight through, there's no split, we can use the regular derivative, plus partial q partial y dy dt, plus partial q partial z dz dt. So now dq dt is equal to, we have to find partial derivatives. So in respect to x first, so that's going to be 8x over 2 times the square root of 4x squared plus 4y squared plus z squared. And then 8 and 2 will cancel to a 4. The next one is times dx dt. Now dx dt is simply cosine t. Plus, this second is symmetric, is just 4y divided by the square root of 4x squared plus 4y squared plus z squared, and then times negative sine t, and then plus dq dz. Now it's just going to be z divided by the square root of 4x squared plus 4y squared plus z squared, and then we have another negative sine t. Now we are not done, because our problem, I'll just erase this and just put 4 over here. We are not done because our problem still contains x and y and z, and you're not supposed to have those. So we are going to plug in x is sine t, and y and z are both cosine t, and see if we can simplify anything. So dq dt is equal to, we have 4x. Now x is sine t, so we have 4 sine t cosine t divided by, now the first two terms, it's 4 sine squared t and cosine squared t. If you factor out 4, you are going to have 4 times 1, right? Because sine squared plus cosine, let me write it out. 4 sine squared t plus 4 cosine squared t plus cosine squared t. That's how the denominator looks like. Plus, minus 4 sine t cosine t divided by, again, the same square root, And you see that these guys completely cancel each other because they have same numerator and denominator. So the only thing that is left is this term minus sine t cosine t divided by the same 4 sine squared t plus 4 cosine squared t plus cosine squared t. So dq dt is equal to, this is a negative sign. So what I can do is I can put 2 and 2, so I can combine the top into sine 2t, and on the bottom I have factor of 4 becomes 4 plus cosine squared t. And I would say that this is the simplified version of the, so all in terms of t. So as you can see, I condensed everything, but the first two terms canceled completely. It was a very good problem to choose, because we see that if you just keep pushing to the next step, some interesting calculations might occur, and this is what happened here. That the first and second term were identical with the minus in between, so they subtract to 0. You can also say add to 0, doesn't matter. Yes? The final answer is negative, yes. I will walk all the way back and add. It is negative. I mean, if you just look closely, there's a negative right there. You see? Right there. There's a negative. Can't miss it. Got a problem? Ooh, the book? It's not mine, don't worry. Don't panic. The next two problems are both very interesting. We are looking into domain of the function. Problem 13 on page 882 says f of xy, you should know that that's your z, right, is equal to the square root of 25 minus x squared minus y squared. What's the domain? Well, you see that your input for this function is region xy, which means that we are going to have a region to be the domain. The way we do this is when we have a square root, we take the argument of the square root and we set it larger or equal to 0. So 25 minus x squared minus y squared needs to be larger or equal to 0. Now we move x and y to the right. and then shift everything to the left. And we get this, which is this, which is a circle with radius 5, but everything inside, including the boundary. No coughing. So that's the domain. Again, another question, same page, problem 17, also asking for domain. G of xy, again, the whole thing is z, ln of x squared minus y. Now for ln, the domain is found by taking the argument and setting it larger than 0, because we have a vertical asymptote at 0. So we have x squared minus y larger than 0. And that's actually an equation. So this is x squared larger than y, which means y less than x squared. So kind of like my coloring skills. Anything under the parabola on the xy plane would be the domain of this function. Any other questions, concerns? Yeah. I don't have a book on me. It's good.
What section was domain dimension?
I believe 12.2. I remember because I hated it. 12 yeah, 12.2. Have another one? Wait, would you get one what are the points that come along? I got an 87. You got 78. You got me. Yes. Tangent? All right. So we already have 3 problems. The first 2 are on 12.3, limits, and then you said tangent plane.
And then can we do a Lagrange one?
Lagrange, yes. You have to embrace the French. That's Pierre over there, please. The problem I'll have to pick one more. 33 and something else. So the first problem is asking us to find the limit as x, y goes to 1 and negative 2 for y squared plus 2xy divided by y plus 2x. Now we know that limit, in a nutshell, is just a fancy way to find the in this case, z value. So we try to solve the problem just by plugging in numbers. If we get 0 in denominator, we are in trouble, and then we have to use something else. So I try to plug values in, and as you can see in denominator, you get 0. Right? So plugging in doesn't work. That means we have to massage the problem using algebra to try and cancel stuff. And we are lucky here because if you factor out y in the numerator, denominator gets canceled. So the answer for this is negative 2. It's clear, right? So what I'm going to do is factor out y, which leaves me with y plus 2x, which is divided by y plus 2x. And these guys completely cancel, leaving just the limit of y. And we know that xy goes to 1, negative 2. There are no x's left in the problem. It's just y, and y goes to negative 2. So the answer for this problem, number 20, on page 893, the answer is negative 2. The following, yes?
So we're going to be, are you going to ask us to compute from different sides? Or
You can't, because you remember infinitely many approaches. Two sides are only in Calc 1, from left and right.
From other points? Or is this okay? I'm saying, like, or should we try from the other angle? Are you right?
Well, see, the trick is over here that you were able to cancel and solve the problem. The two-path ones where you show that the limit does not exist is for the problems where you cannot cancel. You cannot rationalize, you cannot cancel. So you are hoping to run into an issue with two paths giving you two different limits, which actually disproves that limit exists.
So are you going to tell us when we have to do, I think that's what you're asking?
Yeah, but if
Right.
it's 0, 0, then we know.
Yes. Very good. What he said.
0 to 0, then we know.
Yeah, okay. No, you have.
And with a smile, obviously. It's math class, so
Doesn't that?
your happiness is our primary concern.
You were able to factor in, but,
Yeah.
but if you can't do anything, you can 0 to 0.
Happiness and well-being. The next problem is problem 33, which addresses continuity. And the question says at what points in R2 the function is discontinuous. So technically find all points of discontinuity, and they give us f of xy equals to x squared plus 2xy minus y cubed. So we know the theorem which says that if the function is differentiable, it's continuous. Or we maybe don't know the theorem. So this is differentiable everywhere, therefore it's continuous everywhere. So there are no points of discontinuity for this particular problem. I will pick something else, that one. All right. F of xy is continuous on R2 everywhere. Again, I use the theorem which says if the function is differentiable, it is continuous. The function is differentiable everywhere, so it's continuous everywhere. The next problem, we can pick any one of these. 36. whatever. They all look the same. After this is the 33 is the only one of this kind, and all other problems look the same. So here's 36, asking the same questions on continuity, and we have s of xy is equal to 2xy divided by x squared minus y squared. So now when you're looking at this problem, we know that we are going to have discontinuity when denominator equals to 0, right? Because that's when the whole thing explodes. So we have x squared minus y squared equals to 0, which tells us that at any point x squared equal y squared. Wow, that's a lot of points. That's infinitely many points. So for any, we can say y equal plus minus x. So this is discontinuous along the lines x equals y and x equals negative y. That's a lot of discontinuities. So when you take a look at the domain, which is your x and y plane, and remember, you're looking this bird's eye view, right? We're looking from the top, for those of you engineers who don't know what the bird eye view is. Well, it's either one or the other, or you can't dance, it's something, right? So when you look at this, along these lines, y equals x and y equals negative x is where the discontinuities are. So infinitely many points of discontinuities, and they're all on these lines, all of them. So sometimes you get the point, sometimes you get the infinitely many points that are on the line arranged like that. So that's that.
Do you always use x squared minus y squared for that?
That was my denominator. I said equal to 0.
Oh.
Every problem is going to have different denominator, therefore you got the. Well, this is where discontinuities are. Well, you just write a sentence that says all discontinuities lie along these lines. So every point along these lines, you have a point 1, 1, 1, negative 2, stuff like that. Sorry, negative 2, negative 2, and stuff like that. So anything that lies along these lines, negative 2, 2, and so on, they're all. So as long as the same digit with whatever combination of signs is going to be a discontinuity. Yeah, open the book down. So epsilon delta, this time your epsilon delta, this is for honors section, so you guys can relax a little bit, but not you guys. Epsilon and delta now are not lengths on x and y axis. Now they are radius of the disk that is around the point of interest. So as you are looking for the limit, you are looking for the limit earlier. So earlier, we were looking at the limit at the point 1 and negative 2. So for the so if I have the domain xy and I have 1 and negative 2, you are going to have a disk with a radius delta, which builds up a tube. Think of a straw, right? Builds up a tube on top, which is going to hit the surface of the function, and whatever that middle is shoots over to z-axis to read off the value, and you are going to have another tube around the z value, which travels around the value that travels towards. So if you're looking from the top, you have this, and now let's say I'm looking from the X into Z. There is some kind of shape on top. This tube came up. This is a bad drawing. So let's. So Z is going to shoot this way, and these guys are going to shoot that way. So this value in the middle is L. The value on the bottom is L minus epsilon, and the top is L plus epsilon. So if you're looking from the top, you see a disk, and it's a tube that rises. Once it hits the function, it bounces off towards z-axis for us to read the value, and both of these tubes, they're gonna also bounce off, and that creates the epsilon.
How can epsilon be the same distance from the surface?
It's not. You can pick epsilon to be anything, any value. It doesn't have to be.
Your delta would be.
But it wouldn't.
So epsilon's the same. I'm just confused as
You just pick epsilon that will take all of them together. It's not. It doesn't have to be, because you are allowed to pick any epsilon, because the definition says for any epsilon there exists delta. So for any epsilon there exists delta. So you pick epsilon, and then for us to draw we go this way, but the theorem actually works this way. So epsilon is what you pick, and then you will be able to find delta that fits. But delta is the disk. It's no longer just left and right. It's disk. And you can, again, you just take the maximum delta you can fit in. Doesn't matter. Right? It might not be the perfect match on both sides. It doesn't have to be, as long as there is a delta that is contained, which proves that there is a tube right from where the limit came. Awesome. Tangent line. Boss, did you find the problem? Page and number, or you have what's happening with the tangent plane?
It says find an equation of the plane tangent. The following surface at the given point.
Okay, tangent plane.
Yeah.
So what is your function? F of x.
YZ e exponent of xc.
What was that?
YZ
YZ.
to the power of xc.
Like this?
Then
Minus
minus 20 equals 0.
20 equals 0.
Yeah. And the points are 0, 4, and 5.
0, 4, and 5. What? Bye. See you next week.
Bye.
Test is tomorrow.
Good luck, everybody.
Oh man, you can finally sit on your spot.
Is it a minus 20?
Yes.
Okay.
It's either minus 20 or minus zo. But it's not crossed out, so it's definitely 20.
That's what I thought at first.
Yeah. Yeah. We talked about the best possible password, right, that you can have to annoy others. It's a string of capital O's, zeros, ones, and lowercase l's.
Wait.
Yeah.
Oh my god.
Zeros, capital O's, lowercase l's, and ones.
You're evil.
God, hang on.
Oh, anytime I need to extend something on my math lab
If you do have to, like, I don't know, write it out for someone.
for personal password, there you go. Just type this in, nothing to worry about. 1 lowercase l, 0 O.
Well, you could cross it. You could cross the zeros and make the ones.
Why would I? It's perfect like that. Just imagine the license plate that goes
Just for the hell of it.
00 O LL1.
I think they
Just for the hell of it, don't make all the O's uppercase.
exactly that.
Yeah.
Well, there's actually some license plates where it's B88
to just 8 across the board.
Yeah.
Aren't they not allowed to like put O's on license plates anymore?
Anyway, we're supposed to apparently do the tangent plane, so let's do that. We have our equation of the plane is generally the ax minus x0 plus b y minus y0 plus c z minus z0 equals 0. Now, if you remember well, this a, b, and c was the normal vector, but for the tangent plane, we get that from the partial derivatives, right? So the vector a, b, c was the vector of fx, fy, and fz, all computed at 0, 4, 5. So now, all I'm going to do is find these partial derivatives, compute them at 0, 4, 5, and then plug everything in. Partial derivative fx is yz is a constant, e to the xz, and then another z in front, so it's z squared. Giving me, when I compute at 0, 4, 5, I have 4 times 25, so 100. Then I have fy, which is keeping everything else as a constant, so z e x to the z. And fy, when I plug in the 0, 4, and 5, it's going to be 5 only. And finally, fz is the product rule, right? Because we have yz times. So copy the first one, yz, times the derivative of the second, which will give us x as a chain, plus copy the second, times the derivative of the first, which was in terms of, whoops, z, so it's y. To simplify this a little bit, fz is equal to xyz e to the xz plus y x. This should say xz, not xy. And now when you plug in x equals 0, first term dies, and the second term will live with having a number 4 in here. So to put our equation of the plane together, we have fx, which is 100, times x minus 0, plus fy is 5, y minus 4, and then plus 4, z minus 5 equals to 0. You can simplify this by saying 100x plus 5y plus 4z is equal to, we have negative 20, and negative 20 equals to 40.
Do we have to? Like, would you take points off if we just let, like, you know, left it in the x, a, y, b, z, c form?
You can do anyway, it's fine. I just waited for you to ask the question. I knew immediately what you wanted.
I know I can. Would there be a deduction?
No. Why?
Oh.
Do I look that evil? Because I could live to your expectations. So that was the tangent plane. You happy, boss? Yeah, he's smiling. He's happy. Anything else? Yes, which one? Page. I have the book.
Oh, 926. Or 925.
Okay, 926 you said? So which problem?
I was gonna say one from 9 to 16, but like not 11.
11 is on 925. Compute gradient gxy is equal to x squared minus 4x squared y minus 8xy squared, and the point at which we want to compute this is negative 1, 2. So del g of x and y is a vector of partial derivatives. So partial derivative in respect to x is going to be 2x minus 8xy minus 8y squared. And then partial derivative in respect to y is negative 4x squared minus 16xy. So I took the derivatives in respect to x and then in respect to y. This is 12.6. You also need this for Lagrange. So now they want us to compute this at point negative 1, 2. So x is negative 1, y is positive 2. So I have negative 2 plus 8 times 2 minus 8 times 4. And the second one is negative 4 minus 16 times negative 2 when I plug everything in together. So del G computed at negative 1, 2 is, that's 16 minus negative 16, negative 18. And that's a 32, 28. Yes. This is the vector in the direction of steepest descent. Yes. Ascent. And you put the minus in front of descent. If you put negative 18 and negative 28. Yes. See? I am amazing.
Percent is negative.
Yes. In front of the whole thing. So both times. We are all descendants. Fire. Any other questions, concerns? M? No.
What was the which chapter? What's that? Like it's tangent plane. No, that's not right. Well, Lagrange one would be good, but you know, I'm going to be right back because I don't remember.
Oh, it's in the other classroom?
It's in the other classroom.
I erased something on the board. I don't remember what. I did erase whatever was in the middle. So this is your, I guess, 2-minute break.
Oh, yeah.
Lagrange problem 47. Okay, with something awful. So Lagrange problem 47. You're late. Okay. So we have our f of xy. So this is one of the problems where we just grind. All right, so this is not exactly how the problem was posed. The problem is actually two-part problem. I'm working on a Lagrange part, which is taking care of the boundary. But then there's also the inside of the problem, which needs to be taken care of by 4 point, right, the previous section, 12.8, minima and maxima. So the problem is posed as 4x squared plus 9y squared is less or equal than 36. So guys, this is an ellipse, all right? This is an ellipse, cookie cutter ellipse that presses into the surface x squared minus 4y squared plus xy and gets that shape out. So it's an ellipse, elliptical piece that will have a whatever wrinkly top. Now that wrinkly top will have min-max saddle points, which are taken care of by your first derivative in x, first derivative in y, set m equal to 0, so 12.8. And you will keep all of the points that are within the domain of the ellipse, and you will throw away any of the critical points that are outside of the domain of the ellipse. So that's the first part of the problem, which is not Lagrange. The second part of the problem is asking for extreme points, min and max, along the edge, the boundary, which is the equation of the ellipse, so that's why it's a constraint. It has to be on that ellipse. So to solve that boundary part for Lagrange, right? We use Lagrange. There we go. So partial derivative in respect to x is 2x plus y. Partial derivative in respect to y is negative 8y plus x equals to lambda times, and now partial derivative with respect to x is 8x, and partial derivative with respect to y is 18y. So now we finally have our equations. Equation has 2x plus y is equal to 8 lambda x. Next equation says negative 8y plus x is equal to 18 lambda y. And the last equation is, I'm just going to divide through, and we use just the equal sign because remember the less than or equal to is the inside of the ellipse, which is taken care by a previous section. I'm just going to use equal there, and if I'm just going to write 4x squared plus 9y squared equals to 36, and this is our system. Now you solve it in whatever way you can. Standard for problems like this, lambda equals everything else, lambda equals everything else, and then set those equations together, and then you will have that equation and the one on the bottom, the third equation, ellipse, right? And you figure those out. So lambda on the first one is 2x plus y divided by 8x, and on the second is x minus 8y divided by 18y. You set those equal to each other because lambdas are equal on the left. That means that the right hands have to be the same, right hand sides have to be the same, and this is what we get. Now we cross multiply, put everything on the pile. That's 18 times 2, 36xy plus 18y squared is equal to 8x squared minus 64. That's an ugly 4. There we go, 64 xy. Put them all on the pile. So let's keep x squared positive. So 8x squared minus 18y squared. And then minus 28xy equal to 0. So now I have two equations and two unknowns. So I have 4x squared plus 9y squared is equal to 36. This 9 looks like a G. And I can actually divide by 2. Yeah, 18, I can do 16, 4. So divide by 2, I get 4x squared minus 9y squared minus 28xy equals to 0. That's what I said, 14. Thank you. So, how would you solve the system now? How would you solve the system? It will not get rid of one variable, because we have this xy term right here.
Where did you get that second equation?
Which second equation? It's half of the second equation. 2, 9, and 14. 4, 9, 14. Drive it to, yes.
Negative 64xy on one side and 36xy on the other side.
Oh, they add to 100.
Who does?
Yeah. This over here is 100.
Oh, hey.
All right, that changed to 50. Does that help? No. I mean, he makes it correct, but it doesn't make anything factor better or anything like that. No, you solve for either x equals everything else or y equals everything else in the first equation and plug in the second.
Yeah, but how do you get? No, that doesn't do it.
So, what do you need foil? There's nothing to foil here.
Can you take this one?
So we are solving the first equation for x. You want x or y?
Why?
Y. So y squared is equal to, when you divide by 9, 4 minus 4/9 x squared. From where y is equal to plus minus square root of 4 minus 4/9 x squared. And now you plug both of those in the second equation, and then good luck with algebra. So we have 4x squared minus 9y squared, which is 9 times 4 minus 4/9 x squared. That works nice. Minus 50 times x times the square root of 4 minus 4/9 x squared equals to 0. Do you see how an entire equation is in terms of x? Therefore easy to solve, right? Exactly. You'll have to do this again with a negative square root, but that's okay. So 4x squared minus 36 plus 9, and this cancels, so another 4x squared. And then minus 50x square root of 4 minus 4/9 x squared. Because of this minus in the middle, we can just cry. There's nothing we can do. So now this is 8x squared minus 36 minus 50x square root of 4 minus 4/9 x squared equals to 0. It's just a standard algebra grind. You will move the 50x term to the right and then square both sides to kill the radical. So, you know, we'll get this done by 3 a.m. on Saturday. Don't worry about it. No equals 0 now. That's it. And we square both sides to kill the square root, and then you continue grind. So I have 64 x to the 4 minus 2 times about 16 times 36. I'm not multiplying that. X squared plus 36 squared is equal to 50 squared. That's 25 with 2 zeros. X squared times 4 minus 4/9 x squared. There we go. Now you FOIL the right hand side and then combine all the like terms and then use the quadratic equation to factor. So you see it's a little bit tricky, and this is all for positive square root only. Then you do this for negative. And if you ask me how many of these questions are going to be there on the test, 2.
Okay, but of this difficulty level?
No.
Okay.
This is not difficult, this is tedious.
Of this tedious? Of this, is that a word?
Tedious.
Annoyance. Of this level of tediousness, I don't know what that means. Is that a yes or a no?
Tedious level.
No, he just teased me in the face. Yeah.
No, well, I'm trying to play with words and letters to see if your word works.
Okay, well,
The
you
answer is
know what I
no.
mean. Yeah.
Yes.
Okay.
Yes, the answer is no.
Yes. All right. Well, then in that case, I'm not even going to ask my question because
Good.
it's one of those. I'm just going to write.
So give this another 30 minutes and problem is solved. Oh, that was just on the boundary. You still have to do 12.8, which is the middle. Yeah, this is an easy, an hour problem to enjoy.
Oh, I know what I'm looking at. Wait, did you send it to me? Yeah. Oh, I just saw it. It is. Oh, sweet. Ah. I don't want to talk about it. I don't want to talk about it. Why did you say that? That. Nice. George. Yeah, that's it. But I'm talking like it was in 12.8 and it's like find where find no, it's like find the point closest. Find the point on one line closest to the next one.
Any other questions? We have another 17 minutes, and then I have to bounce. Yes, no?
Yeah, hang on.
All right.
Find the critical points of the following.
Uh-huh. Yes.
And then find f of x, y equal to 7x squared minus 3y squared.
Critical points, we are going to look for partial derivatives. fx, in this case, 14x, and fy, in this case, negative 6y. Set each one to 0, and all we get is 0, 0. Done.
find problem 31, page 957.
$31? We did this yesterday.
No, we did 30 yesterday. I'm still a little shaky on it.
All right. So what we have a minimum distance to a surface, which means that our objective function would be the distance formula. We have a surface which gives us our g of x. That's the constraint. 4x plus y minus 1 equals to 0. And we have a distance formula, which would be distance equals to, now in this case, f of x, y, and z. And that would be the square root of x minus plus 2 squared. I'm using the point, right? And then y minus 5 squared plus z minus 1 squared. Observe that our g does not have a z in it. So we are doing the Lagrange multipliers here. Del f equals to del lambda del g. So we are supposed to take the derivatives. I am going to call this square root here a star, because I will have to write it 5,000 times. So our fx is going to be the derivative of the inside, which is 2x plus 2, divided by the square root, so 2 times the square root of a star, and 2's drop. Now fy is going to be y minus 5 over the square root, and fz would be z minus 1 over the square root. Each one of these square root will have 2 in front, but then the 2 will cancel with the derivative of the inside, which is a square. And then we have gx, which is just 4. We have gy, which is 1. And gz, which is 0. So now we have x plus 2 divided by the square root is equal to 4 lambda. The y minus 5 over the square root of the star, which is the whole thing over there, is equal to lambda. And z minus 1 divided by the square root with the star equals to 0. Lambda times 0 is 0. And we have our constraint function, which said 4x plus y minus 1, well, just say equal 1. There we go. So this is my system of equations. And we can immediately see that z is equal to 1. Because when you cross multiply, square root dies. And you have z minus 1 equals 0 from where z is 1. So that one is already done. Now, if you look at the second equation, it's lambda equals everything else. Just plug it in the first. So you have x plus 2 over the square root of a star is equal to 4 times y minus 5 divided by square root of a star. So now square root of a star drops, and you have two equations to worry about. One says x plus 2 is equal to 4y minus 20. And the second equation is 4x plus y equals to 1. So x minus 4y is equal to negative 22. And 4x plus y is equal to 1. And that will give you your x and y, and you already have z, and the problem is solved. So what do? I multiply bottom equation by 4. That will give us the least disturbance in the force. That's going to be 16x plus 4y equals to 4. And now when I add these equations, I get 17x is equal to 22 minus 4 is negative 18. So if all calculations went well, x is equal to negative 18 over 17. And then you can use any of the equations that have x and a y to compute y. So I'll go into original equation. If you give me 4 times negative 18 over 17 minus 1 is equal to negative y. I don't like it. Too many negative signs. So, oh, you're writing in pen? Too bad. So y is equal to 1 minus 4x. Y is equal to 1 minus 4 times negative 18 over 17. And there you have your y, right? 4 times 18. Very good. And 1 can be written as 17 over 17. 89. So what is the equation? Sorry, what is the point? The point is negative 18 over 17, 89 over 17, and 1. Problem.
Lot of stuff. Do we also still have to calculate distance, right? And that's just a plug in.
Yeah, you can just plug in values, but this asks what to find the point, right? And we found the point, so we just walk away. Of course, cool stuff.
three-dimensional representatives of a graph, not so much.
Yeah.
Unless it turns out that that graph, when drawn out, like resembles that.
Yeah.
Always said he was
Yeah. Yeah.
Yeah, no, right.
The graphic?
You ever seen that? That's on that's going on for so it's like a login first? Yeah.
No.
Say it right now. Okay.
The site or
Shut up.
That's all your parents.
Anything else?
Hang on. You see all that? All this? Plug all that in and you get that.
Yes.
That's so cool. Popular curve.
You can also do like a hammer and sickle.
What?
That was on a mathematical Marxist page.
All right, then I guess I'll see you guys tomorrow.
7:30, bright and early. 7:30 p.m. You say goodbye to the stream. Can I do it?
Yes, please.
Bye, stream.
Alex, to close the session.
Goodbye, stream. Yeah, you tried.
Yeah, excited.